We are Hybron, and we have a new composites manufacturing process that will revolutionize lightweight component production with many DoD applications. The industry chooses composites for their lightweight, high strength, and corrosion resistance, which allows entire systems to achieve increased performance, fuel and energy savings, and decreased emissions. The problem is that producing complex parts with composites is very difficult. Traditional manufacturing involves placing each layer by hand, one by one, and this process is difficult to scale with high costs, low throughput, and defects and inconsistencies. As a result, many complex structural components, such as compressor blades, are still made for metal. We have just done something that has never been done before and have developed a new manufacturing process to change this. And we tested our composite blade inside of a fighter jet engine at full power. Our new manufacturing process can produce complex parts at 10 to 100 times the speed of traditional manufacturing, allowing us to be more than 5 times cheaper than titanium at scale. And we have better than 20 times better thickness consistency than traditional manufacturing. Compared to our competition, we have the fastest part production rate at scale. We also have high temperature materials and large part capabilities, allowing us to reach many more applications than other composite startups. Large equipment manufacturers actually want to work with us, and we have received purchase orders from large aerospace primes. Composites is a $200 billion market that will reach $500 billion by 2030. The complex and lightweight structural parts market is over $100 billion, and the compressor blade market is $10 billion. Our compressor blades will increase the efficiency of non-nuclear Navy ship propulsion units, which for the warfighter means less logistical demand for transporting fuels, less fuel expenditures, and less emissions, supporting the sustainable infrastructure and green technologies challenge statement. Our team is well qualified to scale this tech. Brennan and I have 10 years of composites experience. Rahul Singh, our Chief Growth Officer, is a U.S. Marine veteran, former Amazon VP, and was a Los Angeles Regional Engagement Principal at the Defense Innovation Unit. Craig Ellis, our Principal Engineer, is the former Director of Composites Manufacturing for the B-2 Stealth Bomber, and the former Chief Technology Officer of Northrop Grumman. We are also being supported by a strong board of advisors, including 3-star General and former CIO of the U.S. Air Force, Bill Bender, multi-billion-dollar exited founder Jack Barron, Stanford professor and director Fukuo Chang, and distinguished UC Berkeley professor Robert O. Ritchie.
Together, in just 2 years, with $350K, we filed an accelerated patent application, partnered with a world-leading composite material supplier, and successfully tested our composite blades in a fighter jet engine. We have 2 more scheduled pilots, where our customers will commit over $100K in testing costs and risk more than $10 million of capital equipment. After our initial jet engine test, we came out of stealth and gained significant traction. This includes with the top 5 largest defense contractors. We were part of the FedTech Northrop Grumman Technology Accelerator and are quoted as a success story on their website and LinkedIn. We also received a letter of support from one of these primes, supporting our efforts to join this accelerator, and these primes have provided internal research and development funding to help further our development. We have also received support from Space Systems Command, the Air Force's Autonomous Collaborative Platforms Manufacturing Lead, and are developing lightweight composite 155mm artillery shells for U.S. Army applications to solve the munition shortage, increase lethality, and reduce logistical constraints. For the warfighter, this means that they can take more shells into battle at once and need to fire less of them to have the same lethal effects, significantly enhancing survivability and effectiveness. We've also been part of other extremely competitive accelerators and pitch events. Specifically, Ventures for Climate Tech is funded and backed by New York State. Out of over 300 companies that applied, we were one of 10 selected to receive maximum non-dilutive funding, and the only one to have received a personal angel investment from the program director, Jack Barron. These opportunities typically have 5 to 10% acceptance rate. To date, there's not a single accelerator or pitching spot we've applied for and not gotten into. Building on our massive traction, we've raised a $3.9 million seed round to rapidly scale. In the past 2 weeks alone, we built our first artillery shell prototypes, and we also built our 25-foot, 12,000-pound steel skid to serve as the base for our large capital machinery. We would love to have your support as we revolutionize lightweight component production. Thank you.